Hello Year 9. Today we're going to continue our work on probability and we're going to learn about Venn diagrams and two-way tables. So Venn diagrams use overlapping circles to represent relationships between different sets. They're called Venn diagrams because they're named after the English logician. The logician is someone who studies logic, a man called John Venn. And this diagram here is an example of a Venn diagram. Now normally you have numbers in the Venn diagram. So for example, if I put the number 3 in this center overlapping section of the diagram, that would mean that there is 3 people who like both football and cricket. If I put the number 5 over here, that means that there's 5 people who like football but they don't like cricket. If I put a 6 over in this section, that means that there's 6 people that like cricket but not football. And finally, you can also have a number outside of your circles out here. So I'm going to put the number 1 out here. And that means that there is one person that does not like football or cricket. Now, a Venn diagram is one way to display the data, this kind of data where you're comparing two things like football and cricket. Another way to compare them is using a two-way table. Okay, 2 sets of data and two-way table kind of makes sense. So what we're trying to do here, you can see we want to use our same numbers from comparing football and cricket up here. We want to put them into this two-way table. So this first part here is saying that there are people who like cricket and people who like football. So this first little rectangle are the people who like both of them. So that would be the overlapping 3, people who like cricket, people who like football. Then, if we want the people who like cricket but not football, that would be this next part. People who like cricket but not football would be the 6. Then going over to the next column, we want the people who do not like cricket but they do like football. So like football but not cricket is the 5. And finally, we want people who do not like cricket and do not like football. That was the one person outside the diagram. Now, the two-way table also has these totals that you can put around the outside. So what that means is I want to add down the column to find this final number. 3 plus 6 is 9. So that means that there is 9 people who liked cricket, but 3 of them liked football as well, and 6 of them didn't like football. If we add this next column, 5 plus 1 is 6, and you can also add horizontally. 3 plus 5 is 8, which means there's 8 people who liked football, and 6 plus 1 is 7. Now for this last little box, you can add going down the column or across that row there. You should get the same total either way. 9 plus 6 makes 15, and 8 plus 7 also makes 15. And that number 15 represents how many people were involved in putting the results in this little table. So there was 15 people who said whether they like football or cricket. Okay, so they're the 2 different types of diagrams that we're going to be using in this section of work. Let's have a look down here at our examples now. So example number 1, a survey of 80 people found that 36 people play football and 46 people play cricket. Also, 14 people play both football and cricket, while 12 play neither. Okay, so the trickiest part of these kind of questions is often the starting part where you're trying to draw the diagram to represent what's going on there. Now it says to construct a Venn diagram, okay, not a two-way table, so we have to do the Venn diagram. So that means we need the big rectangle around the outside, and we need 2 overlapping circles. Now the 2 sports that we have are football and cricket again. Okay, so let's read through the question again and try to put the numbers in the right places. So a survey of 80 people, now that's the total. That doesn't help me just yet because I need to know all the individual sections. Found that 36 people play football. So that's the total of the football circle, but again, that's got 2 sections. 46 people play cricket, so that's the cricket circle. And 14 people play both. Finally, that 14 people gives me a number that I can work with. So 14 people likes both means that is this section here in the middle. 14 like both. That means if there were 36 people who play football, if I go 36 and I take away the 14, that means that there must be 22 people who just like football. So you can see that together those 2 numbers make the 36 people, right? Then we do the same thing for the cricket. There was 46 people who play cricket. So if I go 46, take away 14, that means that there is 32 people to go in that section there. And there was a little bit more to read in the question. There were 12 people who play neither. So that must be the number outside my circles down here. 12 people who don't like to play either sport. Okay, so now we want to answer a few questions based on that Venn diagram. So in part B it says, how many people play football or cricket? Now this is not probability, this is just saying how many people play football or cricket. So there is 22 people who play football, 14 who do both, and 32 that just play cricket. We would need to add all those together to find out how many people play football or cricket. So that's going to be 22 plus the 14 plus the 32, which makes 68 people. Uh-oh, now I'm deleting my circle accidentally. Let me just fix that up. Okay, so part 2 says how many people do not play cricket. Now the cricket circle is here. I want everything outside that circle, which would be the 22 and the 12. So 22 plus 12 means that there was 34 people who do not play cricket. How many people do not play football? So this time we don't want anybody in the football circle, so we want the 32 and the 12. So 32 plus 12 makes 44. And how many people play only cricket? So we want cricket players, but we don't want the ones who play football as well. We want only cricket. So there's 32 people who only play cricket. Okay, part C. If one of the 80 people, so remember there is 80, and if you add up all the numbers in that diagram, you will get 80. So if one of the 80 people was randomly selected, find, now it says P, now remember that P stands for probability. We want to find the probability that the person plays football and cricket. And means they have to play both. That is this overlapping section here, the 14. There is 14 people out of the 80 who play football and cricket. Now simplify that on your calculator and you get 7 out of 40. Part 2 says, find the probability that they play neither football nor cricket. That means that they don't play football or cricket. There is 12 people who don't play either one of those sports. So that's 12 out of 80. Type it in your calculator and simplify to get 3 out of 20. Part 3, find the probability that they play only cricket. So just cricket, not the ones who play football as well. Only cricket, there is 32 people out of the 80. That simplifies to 2 out of 5. On the next page, question 2. 32 students are asked about whether or not they have ever owned an iPhone or an Android phone. 24 students have owned an iPhone, 15 have owned an Android phone, and 8 have owned both types of phone. Construct a two-way table to illustrate the results. So this time we want a two-way table. So we need to draw a vertical line down here, horizontal line, one across the top. So we want to know the two different things that we're comparing, and that is we want people with iPhones, so you either have an iPhone or no, you don't have an iPhone, so no iPhone. Or maybe you've had an Android phone. And the other option is that you have not had an Android phone, so no Android phone. Okay, so let's see if we can put the right numbers in the right places. So let's read through that again. There was 32 students. Now that actually tells us this number here. The total should be 32. We're asked whether or not they have ever owned an iPhone or an Android phone. 24 students have owned an iPhone. So for an iPhone, oh, I need one more line on my diagram here. I need a line across here. There are 24 students in total who have owned an iPhone. Remember, some of them may have owned an Android phone as well. 15 have owned an Android phone. So Android phone, there was 15 who owned that. My 32 was the total, sorry, that needs to be down here. And 8 have had both types of phone. So iPhone and an Android phone, there should be an 8 that goes in there. Now that still leaves quite a few gaps in my table. So what we can do, remember that the numbers have to add across the columns or down the rows, so we could use that to help us find the missing numbers. So 15 is the total here. If I go 15 and I subtract the 8, that means that this number here must be a 7. I could do the same thing here. If the total is 24, 24 take away 8 is 16. Okay, what if I use this 32? 32 subtract the 15 means that that one there is 17. 32 subtract the 24 is 8. Now there's one last one to find. What if I do 8, subtract the 7, and I get a 1? So once you've got all the numbers in your two-way table, again we want to answer some questions. So the part B is finding how many. So how many people have not owned an Android phone? So no Android phone. In total, there was 17 people who have never owned an Android phone. So 17 goes in here. Have never owned a phone, that means never owned a phone at all. So no iPhone and no Android. That intersects here at the number 1. There is one person who has never owned either type of phone. Part C, find the probability that a randomly selected person has only owned an Android phone. So, Android phone has only owned an Android phone. No iPhone, so they can't have both. We don't want Android and iPhone. We want Android, but no iPhone. Means there is 7 people who have owned only an Android phone out of our total of 32 people. The next one, find the probabilities. That's why I'm doing fractions, because we're doing probability here. find the probability that the person has owned an Android. Now this time we don't care if they've owned another phone as well. As long as they've owned an Android phone at some time, that means that there will be 15 people who have owned an Android phone out of the 32. And finally, part 3, find the probability that the person has owned an Android phone and an iPhone. So they have to have had both. That would be this 8 people here out of the 32, and that fraction actually does simplify in your calculator to be a quarter. Okay, so that's the end of our examples today. So over here on page 10 is where your questions start on Venn diagrams and two-way tables.